Have you ever wondered how scientists figure things out? How do they test new medicines or understand how the universe works? The answer lies in experiments. Imagine experiments as exciting detective stories where scientists try to solve mysteries by carefully observing and analyzing clues. These clues are called variables. In the world of science, experiments are like carefully designed games with specific rules. Scientists use experiments to see if one thing causes a change in another. These experiments help us understand how the world works. Think of it like baking a cake. You combine ingredients like flour, sugar, and eggs in a specific way to create a delicious treat. Similarly, in an experiment, scientists change and control different factors, which we call variables, to see how they affect the outcome. By understanding these variables, we can unlock the secrets of the natural world and make amazing discoveries. So let's put on our detective hats and explore the fascinating world of variables. Every good experiment has a star, and that star is the independent variable. This is the factor that the scientist deliberately changes or manipulates to see its effect. It's like the independent variable holds the master key that unlocks the secrets of the experiment. Imagine you're curious if the amount of water you give a plant affects how tall it grows. In this case, the amount of water you give each plant is the independent variable. You are in control of this variable and get to decide how much water each plant receives. To make sure the experiment is fair, you'll keep everything else the same for each plant, like the type of plant, the amount of sunlight it gets, and the type of soil it's planted in. By changing only the amount of water, you can observe how this single change affects the plant's growth. Now, what happens when you change the independent variable? That's where the dependent variable comes in. It's the effect or outcome that the scientist measures or observes in response to changes in the independent variable. Think of it as the puzzle piece that fits into the experiment. Let's go back to our plant experiment. The height of the plant is the dependent variable. It depends on the amount of water each plant receives, our independent variable. As you change the amount of water, you'll measure how tall each plant grows. The dependent variable is what's being measured or observed in the experiment. It's like the answer to the question the scientist is asking. In our example, the scientist wants to know if different amounts of water affect plant growth, so they measure the height of each plant to find out. In an experiment, it's important to focus on the relationship between the independent and dependent variables. That's why scientists use controlled variables to keep everything else constant and fair. Controlled variables are like the referees of the experiment, making sure everything stays balanced and unbiased. Think back to our plant experiment. We want to make sure that any differences in plant height are due to the amount of water, not other factors. So, we keep the type of plant, the amount of sunlight, and the type of soil the same for all plants. These are our controlled variables. By keeping these factors constant, we can be more confident that any changes in plant height are directly related to the different amounts of water we gave them. Controlled variables help us isolate the effect of the independent variable on the dependent variable, leading to more accurate results. Section 5. A symphony of variables. Understanding their interplay in research. In research, understanding the interplay between independent, dependent, and controlled variables is like understanding the different instruments in an orchestra. Each variable plays a crucial role in creating a harmonious and meaningful outcome. The independent variable sets the stage, the dependent variable responds to the change, and the controlled variables ensure a fair and unbiased performance. By carefully manipulating and controlling these variables, scientists can isolate the effects of specific factors and draw meaningful conclusions about the world around us. For example, in a medical study testing a new drug, the independent variable might be the dosage of the drug given to patients. The dependent variable could be the patient's blood pressure, and the controlled variables might include the patient's age, gender, and overall health. By carefully controlling these other factors, researchers can isolate the effects of the drug on blood pressure and determine its effectiveness. Section 6. Drawing clear conclusions, the power of variable identification. Identifying and understanding variables is crucial for drawing accurate conclusions from research. When we know which factors are being changed, independent variables, and how they affect the outcome, dependent variables, we can make sense of the results and avoid misleading interpretations. Imagine a study claiming that drinking coffee improves memory without controlling for other factors like sleep or stress levels. The results might be misleading because other variables, not just coffee consumption, could be influencing memory performance. By identifying and controlling for these other variables, researchers can isolate the specific effect of coffee on memory and determine whether a true relationship exists. This meticulous approach to variable identification ensures that scientific findings are reliable and contribute to a deeper understanding of the world. Section 7. Real-world applications, variables in action. The concept of variables extends far beyond the walls of a laboratory. Understanding variables is essential in countless real-world scenarios, from everyday decision-making to solving complex problems in various fields. For instance, imagine you're trying to improve your study habits. You could treat this as an experiment by changing your study environment, independent variable, and observing how it affects your grades, dependent variable. You might control for other factors like study time and sleep to isolate the impact of the environment. Similarly, businesses use variables to analyze marketing campaigns, optimize production processes, and understand consumer behavior. By manipulating factors like advertising channels, product pricing, or website design, they can measure the impact on sales, customer satisfaction, and brand awareness. Section 8. Beyond the basics. Exploring other variable types. While independent, dependent, and controlled variables form the foundation of experimental research, other variable types contribute to a more nuanced understanding of complex phenomena. These include confounding variables, mediating variables, and moderating variables. Confounding variables are like uninvited guests at a party, interfering with the relationship between the independent and dependent variables. They create confusion by suggesting a false relationship or masking a real one. For instance, in a study on exercise and heart health, smoking could be a confounding variable if it's not accounted for. Mediating variables explain the process or mechanism through which the independent variable influences the dependent variable. They act as intermediaries, bridging the gap between cause and effect. For example, in a study on stress and illness, the mediating variable might be the immune system, as stress weakens the immune system, making individuals more susceptible to illness. Moderating variables, on the other hand, influence the strength or direction of the relationship between the independent and dependent variables. They act as volume knobs, amplifying or diminishing the effect of one variable on another. For instance, in a study on social support and coping with stress, gender might act as a moderating variable, with Section 9. The foundation of knowledge. Variables as building blocks. In conclusion, understanding variables is fundamental to scientific inquiry and evidence-based decision-making. By identifying, manipulating, and controlling variables, we can unravel the complexities of the natural world, test hypotheses, and draw meaningful conclusions about the relationships between different phenomena. Just as bricks build houses and words form sentences, variables are the building blocks of knowledge. They provide a framework for asking questions, designing experiments, and interpreting data. By embracing the power of variables, we embark on a journey of continuous learning, discovery, and innovation, ultimately contributing to a deeper and richer understanding of ourselves and the world around us. As we continue to explore the vast landscape of knowledge, variables will remain our steadfast companions, guiding us towards a brighter future illuminated by the light of scientific understanding.